In this video, I'll be showing how external modules can be utilized in a project. External modules allow code to be compartmentalized. This permits more organized source code management and allows you to more easily find where specific functionality may be located based on the name or purpose of a function. You could create a module that contains all functionality for a specific part of your program, for example, audio format functionality. Modules also allow for more intuitive coding, which can lead to better collaboration. With everything organized, other contributors can find code more easily, and it becomes simpler to handle code merges. Having module names available in code allows you to easily identify where code came from. For example, if you are working on an archival program with multiple compression formats, you could have a module for each format, and each module can have a function named compress. In the code, you could access the compress function through the module name, so you always know which format you are compressing data into. Here are some details regarding modules. Modules can have any name. They use a hierarchical organization, similar to navigating through folders in a file system. All modules are private by default, and you can use the pub keyword to make a module public. External modules can either be a directory, which can contain additional modules, or they can be a file. Here is a directory structure for an example project that splits up an application named app and a library named demo. This configuration, which I always recommend when making an application, allows for multiple binaries under the bin directory here at the top, and a single library file in any directory you're choosing. The information on the right needs to be indicated in the cargo.toml file to use this configuration. In our cargo.toml file, we have a lib section and a name key and a path key. The name is the name of the library that will be accessed in the code, and the path is the relative path to the actual Rust source file. In this case, our library is named demo, so we can use the word demo to access it in the code, and the path will be at source/lib/mod.rs. If we take a look at our directory structure, this dot here will indicate src, and then we go down to lib right here, and then we go down to mod.rs. So right here will be the entry point of the library, and all the other modules can be defined from here. If we take a look at our bin directory here, we have an app.rs. All of the Rust files within a bin directory are going to be generated as an executable file. So we'll have an app executable that'll be generated when we build the program. And if we add more Rust source files here, then each one will have its own corresponding binary. Now let's take a look at how to declare some modules. If we look at our mod.rs down here, and this will be the source code, we have pub mod codec and pub mod transcode. These lines are declaring two separate modules. Our codec module is here, codec.rs, and we also have a codec folder. This codec folder will have supplementary code needed by our codec module. We also have a transcode.rs, and this module will exist only in that single file. You'll notice that these lines of code here end with a semicolon instead of the curly braces that we saw in the previous modules demo. This is how the Rust compiler determines whether we have an external module or one in the same file. Inline modules will have all of their code in the same file with curly braces, and external modules will have code in a different file and they end with semicolons. We are working with external modules, so we use a semicolon at the end to indicate that the module exists as another file. So when we have a semicolon, Rust is automatically going to look for a codec.rs and a transcode.rs in the same directory. So now we're taking a look at the code for codec.rs. We have a pub mod declaration for audio and video. Since it ends in a semicolon, this audio declaration refers to this source file, and this video declaration refers to this source file. We know this because we have a codec.rs file and a codec folder. So everything within this codec folder belongs to codec.rs right here. This makes it easy to split up one module into multiple smaller modules that have other functionality related to the codec module. Next, we'll take a look at the video module here, and its source code declares two additional modules. We have H.264 and VP9. We'll see that we have a video folder, and here's our two modules there. So our H.264 refers to this source file, and VP9 refers to this source file. Lastly, we have the FLAC and MP3 modules, which are here, and they're both defined in the audio.rs module. You'll notice that we're using the pub keyword here on all these modules, and this ensures that all the code can access functionality contained within. Without the pub keyword, the modules would only be accessible by their containing module and any submodules. For example, if we remove the pub keyword from the H.264 module, we would only be able to access the H.264 module from the video module here and the VP9 module here, but not from anywhere else. This can be used to encapsulate private functionality that's not meant to be exposed to other parts of the code. Here we're taking a look at the source code of the FLAC module, which is deep within the hierarchy. The FLAC module exists within the audio module, which exists within the codec module, which finally exists within the demo module, because the demo module was set up in the cargo.toml file. Since code is isolated within each module, we need a way to access functionality from different modules. So if we're in the flac.rs file and we want to access the MP3 module here, we need to use super, and the keyword super will go up one level. So if we're in flac.rs and we want to go up one level, we'll end up in the audio module. So we can go from FLAC to audio. And audio contains the MP3 module, so we'll be able to access MP3 from there. So we use super MP3. And then to traverse through the paths in the module hierarchy, we use the path access operator, which is 2 colons. When we have use super path access MP3, we're bringing in the MP3 module into scope, and we'll be able to use it. And we'll see in our function sample, we're able to use MP3, path access, and then some function. Even though we're using MP3, we're not actually accessing anything within the MP3 module until we again use another path access operator to access it. It's not necessary to have the use line. We could just use super directly in our code, path access, MP3, path access, some function. Using super is fine if we want to access everything from the FLAC module, but sometimes we want to access everything from the root. So we want to access things from this mod.rs file because that's what we set up in the cargo.toml. To do so, we can use the crate keyword, and crate will automatically start at the very root of the library, which is mod.rs, because that's how we configured it. So if we want to access the MP3 module from the root, we use crate, which will be mod.rs. Then we use access to go to codec. We jump into the codec module. Then we jump into audio, which is here in the codec module. And then finally into MP3. And if we want to access the H.264 module directly from the FLAC module, we can use super. So super will go up to audio. We use super again, go to codec. Then we use video to drop down into video. Then finally, H.264, we can drop down into H.264. If you end up in a situation where you have multiple supers, it's usually a good idea to just use crate instead, because if you move the module, then these supers are going to refer to different places, and you'll get an error when you try to compile your code. It's also possible to assign an alias to any arbitrary module path. We can use the as keyword to assign an alias in our current scope. Here, we take the crate transcode module and assign it an alias of TC. This way, we don't need to type out transcode every time we want to use the module. Here on the second line, we use the module with TC, path access, some function. And this is great if you're going to access lots of information from a module and just want a quick shortcut to reduce the amount of typing. Sometimes modules can become nested fairly deep within the module hierarchy. When this happens, it's possible to re-export modules to a different point within the hierarchy. This is accomplished with the use keyword that we've been using so far. Whenever this keyword is used, it's possible to access the module from that specific point in the hierarchy. In this example, we can see that we're taking a look at the codec.rs file source code, and we have a pub use line here. So we have our audio and video modules declared, and then we're also pub using audio MP3. This pub use is re-exporting the MP3 module to the same namespace as codec.rs. And what this means is we'll be able to access this MP3 module directly from codec here. So we'll be able to do a use crate codec MP3 instead of having to go through the audio library here. Let's recap. Modules are organized hierarchically. We can use super to go up one level in the hierarchy, and we can use crate to start from the very top. The as keyword can be used to create an alias for a module. The mod keyword is used to declare a module. And we won't use curly braces for external modules, and will instead use semicolons. Modules can be re-exported with the use keyword. Pub indicates the module may be accessed from anywhere. Omitting pub restricts access to only the containing module and submodules.